This conference will now be recorded.
So we have officially begun now Unit 3. So we're on the home stretch for this course. I'm just waiting for the last minute submissions from the testing center for your um, scrap paper. So as soon as I get those, I'll be grading your tests. Remember, I grade every single problem by hand. I go through every one of them. So if you just put something in the wrong format, but the answer is correct, no, don't worry about that. I always catch those things. Okay. So another thing as a reminder, I just posted out there in the announcements a reminder that don't forget Project 2 is due tonight, and you want to make sure that you submit that no later than 11 p.m., and that is Central Time. So that's why I actually put the time so it would click for those of you who live up here in Northwest Indiana. We do follow the Central Time Zone. For the rest of you, if you're in another part of the state, it is then 11:59. So it's due no later than. So you got to submit before 11 p.m. tonight. All right. So just as a quick reminder, I have that. Let me see. I have that pulled up. Project number 2, that is the financial project. Remember, you are going to be comparing your salary to that of the high school graduate who's making 19,000. So you have to compare in every one of these scenarios. You're going to be comparing your income. Remember, you want to be doing absolute and relative change statements there. And don't put something in there like the absolute different changes or the relative changes, because you really wouldn't say that to somebody when you were talking to them. You can just say that, the difference between the numbers is, I don't know, $10,000, which is an increase of, 20% or something to that effect. So I shouldn't see the actual words absolute and relative change, because you wouldn't use those in talking with somebody. Okay, but that's what we would be doing to help explain that. So then you're going to look up housing comparisons. Remember, you don't necessarily have to live where you're at now. If you do plan on moving, look up housing costs for that area. I do need the references from where you got this information from, so don't forget to give me the references there. And then retirement comparisons. Once again, you're comparing yourself with your future salary to the high school graduate making 19,000. Once again, you're doing those comparison statements. What did I put into Excel for sections 2 and 3 here? What exactly did I type into Excel? What did it give me back as the number? And then the last part is $1 million retirement. So we're assuming that it's got that 5.75 as the return. And, how many years is it going to take to reach $1 million? So this is, you're basically just changing the equation and just the number of years there. So that's what's so nice about Excel, is you can just change one number and it could calculate the rest of that for you. All right, so definitely go through this checklist, because I'm going to be looking through this to make sure all of this is included. Remember, you want to make sure that this is your own work, because it does go through a program that detects things, and it tells me where I got it from, or where you got it from, whose paper it was, and everything. So please keep in mind, keep your own work here. All right, where it says here, submit both Excel and Word file, I do not need your Excel file. So I'm just wanting to grade your paper. So this is a paper. This is not a bunch of bulleted items or numbered questions. This is a paper. So you should start out with an introductory paragraph. Usually people in their introductory paragraph talk about why they chose the profession that they did. And then you go into the different parts of the paper. Remember, new idea or new concept, new questions means a new paragraph. So just like in your English papers, I should see something that's coherently written and properly written. I should not see one giant paragraph with misspellings and things. It's very hard to grade or to even read something that is one giant paragraph and it just keeps rambling on and on. So you want to, we're working on our communication also in here. So make sure that that's appropriate. And then at the very end, you want to conclude everything, uh, based on this, what did you learn about, working on your future with Ivy Tech and getting your degree? Okay, so, make sure you have that concluding paragraph also. Okay, so just a reminder, that's due tonight. Alrighty, so we are, like I said, into Unit 3. And in Unit 3, we're going to be doing a few sections on conversions. And conversions are pretty important, especially any of you who might be going into the medical field because you heavily use conversions. Now, it was kind of funny when I started talking about conversions one time a few semesters back with one of my face-to-face classes. I had a student in my class who was going to be a nurse, and she says, well, I don't need to know how to do those conversions because all I have to do is plug in the information into the little computer that gives the dosages or that gives the medication, and it's going to give me the proper amount. And I said, well, what do you do if the power doesn't work? So what if you're in an area where you have a natural disaster or you're doing triage out in the field or something and you need to know how to convert something? So it was kind of unusual, but I've never heard a question like that. So conversions, doing these measurement conversions, they're pretty important here. So I just kind of want to point some of these things out. So we're going to be going through this. Let me see, I want to put these a little bit bigger here. There we go. So you are going to be able to use, once again, your reference sheet. So the whole one side of the reference sheet is going to be showing all the conversions. Now, we have the US conversions on this sheet. We have the metric conversion relationships here in the middle. We have some of the more popular conversions between US and the metric system. And, how do we work temperature? We are going to be talking about carbon dioxide emissions, which is pretty interesting. We'll get into that in a future section. And then we have some special conversion rates and just some formulas to remind ourselves of. So you definitely want to get familiar with this sheet, know where all these conversions are. If for some reason we need you to do a conversion with something else that's not on the sheet, and we know that it's not anything you deal with on a normal basis, then we would give that conversion to you. So notice up here in the US customary units, we don't have time listed. We pretty much know that, time, we have 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. So, we're expecting you to know some of these basic pieces of information there. Okay. All right, so as we're going through this, we're going to be talking about setting up unit conversions using identity ratios. Now, I cannot express enough how important it is to be setting it up correctly. All right, a lot of people try to set things up and they don't necessarily use the identity ratios, and we'll talk about that. But it's really important, and as long as you set everything up correctly, you should have no issues getting the correct answer. So let's just go through a typical scenario. So if they asked us the question, how many days are there in 6 weeks? Well, what would we do? We know that there's 7 days in a week, and if I'm saying 6 weeks, I would pretty much just multiply, right? Well, what we're basically doing is an algorithm. Okay, so the definition of an algorithm is just a step-by-step procedure for doing some sort of a calculation. So that's what we're going to be doing in this section. We're going to be using an algorithm, a step-by-step procedure for calculating and switching from one unit to the next. Okay, so what was the algorithm here? We basically just multiplied the number of days by the number of weeks. Okay, so over here, we have what we refer to as an identity ratio. Sometimes they call this the factor label method. Sometimes they call this a unit fraction. It just depends what you've heard this identified as. So basically what we're looking at is we're going to be setting up a fraction or a ratio where the numerator and the denominator represent the same amount. The only thing that's different is the units. So when we look over here, since 7 days is the same thing as 1 week, they both represent the same amount of time, we can come up with two different identity ratios here. All right, so the first identity ratio would be 7 days over 1 week. And that equals 1 unit. Okay, it means the same thing. Or we can take the reciprocal of that, so flip it, 1 week over 7 days. Now, the reason why we're using these identity ratios or unit fractions is because we're going to be setting up some of our problems using this idea of identity ratios and these fractions here. So when things get a little bit more complicated, some of these, yeah, we could do in our head, but when they get a little bit more complicated, it really does help to follow this algorithm setting this up. So let's see how we could have set this one up here. All right, so here's our example here. How many days are in 16 weeks? So when I want to calculate a conversion here, I start with what I've been given. Okay, so I've been given 16 weeks. So I'm going to start saying 16 weeks, and I want to put this in fraction form because I'm going to be using these identity ratios or unit fractions here. So I'm going to put this over 1 to kind of help set the pace that I'm putting it in fraction form. Sometimes you see it over 1, sometimes you don't, but it really does help when you start setting it up in fraction form. All right, now I know I want to go from weeks to days, so I have to use a conversion that's going to take me between the two. Well, which one of these identity ratios is going to be the proper one to use? So what I want to do is I want to cancel out the units that I don't want anymore. So remember, when we're canceling out something in common, it has to be from numerator to denominator. So in this case, I want to use this identity ratio where days is in the numerator and weeks is in the denominator so that these are going to cancel out. Okay. Now, typically when I'm just converting from one unit to another unit, whatever unit I want to end up with should remain in the numerator. Okay, that's what I want to have. It should remain in the numerator. The only time it might not remain in the numerator is if I'm going to be converting a rate, and a rate is something that has 2 units to begin with, like miles per hour. It automatically had 2 units in there. Okay, and we'll get to those eventually here. Okay, so now what do I do after I've set everything up and days is in my numerator? That's what I want to convert to. I simply follow the rules of fractions. I multiply all my numerators here. I multiply the denominators and I divide at the very end. Well, in this case, my denominators are all 1, makes my life so much easier. And so I just simply had to multiply my numerators and I wind up with 112 days. Okay, so this is the basic setup and the algorithms that we're going to be following for doing our conversions. I cannot stress enough how important it is to put the units down. It is very, very important because we're going to be getting into more complicated conversions here. This is a very simplified example here. All right, so you can see here's what we have. We started with the units, and this is every time I do this, this is what I do, even when I'm, working up answer keys and things like that. So it says an average pregnancy is 280 days. How many weeks is this? So we know there's what, 7 days in 1 week. Well, I want to set up my conversions here. Start with what I know, put that over 1. I want to cancel out days, so that should be in the denominator here, and weeks should be in my numerator. I'm going to put in the numbers next and then follow the rules of fractions. So notice I multiplied my numerators, multiply my denominators, then I get the fraction. Now I'm going to do the division at the very end, and I get 40 weeks. Okay. What two identity ratios can you create from one hand is the same thing as 4 inches? Okay, so we know they mean the same thing. They represent the same amount. Okay, so this is how they measured horses. All right, so like somebody would put their hand sideways, all right, and they would measure how tall a horse is. And so here we have the world's tallest horse, Big Jake. You know, this is in the Guinness World Book of Records. Based on one hand is the same thing as 4 inches. All right, so if I start it with hands, I want to get rid of hands, so that's got to be in the denominator here. And I want inches in my final answer. Plug in my numbers, follow the rules of fractions, and get my final answer here. Okay, and here's another example using this idea here with the smallest horse, Thumbelina. Okay, I'm trying to get out of this mode here. There we go. All righty. So it says, let's take a look and let's see how much we know about the English system. All right, so there are 12 inches in a foot, 3 feet in 1 yard, 5,280 feet in a mile. Well, if you can't remember that 5,280, that's on the reference sheet there. Okay. We should all know time, 60 seconds in a minute, 60 minutes in an hour, okay, 24 hours in a day. This one, if you're not regularly working with recipes and things, you might be a little unclear about the ounces and cups and pints and so on. But once again, this is on the reference sheet. So there are 8 ounces in 1 cup, 2 cups in a pint, 2 pints in a quart, and 4 quarts in a gallon. Okay. And then for weight, we're going to be dealing with 16 ounces in 1 pound, and there are 2,000 pounds in 1 ton. So all of the ones that you probably wouldn't deal with on a regular basis, like the fluid ounces, okay, or the weight in ounces, and how many feet in a mile, those would be on your reference sheet there. Okay, and here's a copy of the top of that conversion sheet there. Okay. All right, so how would I do a conversion here? Let's take a look. So what identity ratio would you use to convert 27 feet to yards? Well, is there something that goes right away from feet to yards? So in this case, yes, there is. All right. So 1 yard is the same thing as 3 feet, or we could have said 3 feet is the same thing as 1 yard. We could have done the reciprocal of that, the flip of that. Which one would I use? Well, I want to get rid of feet. Okay, so I start with what I know, and I always get in the habit of putting it over 1. Sometimes people don't, but I always put it over 1. And then multiply by your identity ratio here. So feet cancel out. Yards is what I want in my final answer. So yes, that is in the numerator. Follow the rules of fractions, and I get my answer as 9 yards. And then the next one is converting 15 yards to feet. Notice we use the reciprocal of that identity ratio we just used because we want yards to cancel out that time. Okay, here's a few more examples with gallons and quarts and tons and pounds. Okay, now, sometimes we're not going to have the conversion that goes from one conversion factor to the next. Sometimes we're going to have more intermediate steps. And here's a great example of that. So it says, let's convert 1 gallon 2 ounces. So I don't know about you, but I really don't remember how many ounces on a regular basis is in a gallon. So I always just do the conversions to the next best unit that I can think of. And so here's one where it has multiple steps. So what have I been given? I've been given 1 gallon. And so I usually like to put mine over 1. All right, the next set of conversion factors. I don't have gallons to ounces on my conversion sheet, but I do have gallons to quarts. So that's the next best thing. I want to put gallons in the denominator so they cancel out. So now I'm at quarts. Once again, on my sheet, I don't have quarts to ounces, but I do have quarts to pints. So that's the next best thing. So I want to put it where quarts is in the denominator here, and it's going to cancel out. Pints is in the numerator. I still don't have ounces from pints to ounces, so I'm going to go to cups, and there's 2 cups and 1 pint, so pint goes in the denominator here. These cancel out. Now I'm at cups, and I can see I can go from cups to ounces. There are 8 ounces in 1 cup. Okay, so I can cancel out my cups here. Remember, ounces is what I wanted in my final answer, the unit there, and that is in the numerator where I want it to be. And so that's my unit here. So I look at all the denominators are all 1. Ugh, that makes my life so much easy. So follow the rules of fractions and multiply all those numerators, and I can see that my answer would be 128 ounces. Okay, so remember, sometimes you're not going to have the conversion factor that's going to take you there immediately. Sometimes you're going to have to go to the next best step. Okay, so that's what we're looking at, especially when we get into the conversions between the metric system and the English system. It's not always there. Okay, so we'll talk about that in a moment. Now, if for some reason you knew one of these intermediate conversion factors, let's say that you knew that there were 32 ounces in a quart, okay, you wouldn't have to write every single one of these steps here. You can take a shortcut. So in this case, you weren't quite sure, still ounces in a gallon, so you went to quarts, but then you knew that there was so many ounces in a quart. So then you can use one of these intermediate type things. Now, by using this one intermediate conversion, it helped us wipe out 3 steps here. Okay, so if you know some of these intermediate steps, that's perfectly fine. For the exam, just make sure that you write that on your scrap paper there so I can see your train of thought going from that. Okay, so it's perfectly fine to do something like that. But, we did worst case scenario. If you couldn't remember any of the steps along the way, you just keep doing those conversion factors there. You still wind up with the same answer. All right, so here's an example. Math 123 lasted 14,000 seconds this week. How many hours is this? Can we fill in these units here? Okay, so here's what I began with. Put it over 1. I want to convert first from seconds to minutes. Okay, so seconds goes in the denominator. Then I pencil in my numbers. Now I'm at minutes and I need to go to what? Hours. So 60 minutes in an hour. Okay, so in this case, minutes are going to cancel each other out. Then I plug in my numbers here. Now, be careful in this case. Look at the numerator. I got 14,000 times 1 times 1. Okay, so 14,000 is going to be in my numerator. My denominator, though, is going to be a little bit different. Notice I have 60 there 2 times. I don't go, 60 times 2. Remember, this is 60 times 60. That's one of the most common mistakes I see happen. They forget that, I have to multiply these in the denominator with each other. So the denominator is going to be 3,600, not 60 times 2, 120. So be careful with that, okay? And then you can get your final answer there, and here's my units was in the numerator. Okay, so just watch out for things like that. You're multiplying the actual values there. Okay, here's one with cooking. seems like cooking conversions are our most popular conversions that you see. Okay, we had 3 quarts. How many cup-sized containers will this fill? Okay, so I went from quarts to pints, then from pints to cups, and I wind up seeing there are 12 1-cup serving sizes. All righty. Okay, if I was at inches and I wanted to convert to miles, first we would convert inches to feet. Then we know there are 5,280 feet in a mile. So, what steps would I use to get there? Okay, so that is pretty much the English or the customary system. That's what the United States uses. Now, pretty much almost every other state or country in the world uses the metric system. There are only 3 places in the world that use the English system. It's us, and I have forgotten the other 2. I always know them and I forget them right at the time I want to talk about it. But there's 2 other countries throughout the world. I think it's like Liberia and someplace else, something, different. But everyone in the world uses the metric system. And I can tell you why we haven't converted to the metric system all the way. It's not that it's any harder. It's actually much easier. It's just that it's going to cost us money in the long run to do the conversions. But believe it or not, we have been doing conversions slow but sure. Just think of all the manufacturing plants we have. Most of the manufacturing plants that have been around since the turn of the century, car manufacturers, steel, things like that, they've used the English system. To do a conversion to the metric system would cost a great deal of money, changing out all kinds of equipment for the right size pieces. So, I know for a fact, because my husband works in things like that some of the countries have been slowly doing some of the conversions to the metric system. All right, so that's pretty much why we haven't converted. It's a matter of money. But let's take a look at metric relationships. Now, in the metric system, we pretty much deal with a set of prefixes. And all these prefixes are based on powers of 10. That's what the metric system is. That's why it's so easy to use, is because we're talking about powers of 10. And we're basically talking about just moving the decimal either to the left or to the right. The only thing that's going to change using the metric system is the name of the unit. That's it. Okay, so when we look at the metric system and we want to be converting, we first want to deal with the unit. And notice the unit is where we have one of those. So we have meters. When we're talking about the length, when we're going to measure how long something is, we're talking about the meter. When we want to talk about volume, all right, what would fill something up, we're going to talk about the liter. So remember, we buy 2-liter bottles of soda. And then when we talk about how much something is going to weigh or the mass of something, we want to refer to that as grams. So that is the only thing that's really going to be changing, is the name of the unit. Now, when I have 10 of these units, okay, like say I have a meter. If I have 10 of these, I have a decameter. So that's DA, stands for decameter. All right, if I have 10 times 10, which is 100, I'd have a hectometer. And then 10 times 10 times 10 would be 1,000. I have a kilometer, or a kilometer is what we usually say. All right, so 1,000 of these meters is the same thing as 1 kilometer, or kilometer. All right, now these are all the units. When we go to the left, they're getting bigger and bigger. When we go to the right, they're getting smaller. We're getting below the decimal point here, okay, because it's less than 1. So now instead of multiplying by 10, I'm going to divide by 10. So 1/10 would be a decimeter. Then 1/100th would be a centimeter, and 1/1000th would be a millimeter. All right, and so it's really easy to remember these units if you use this little mnemonic. So it's kind of funny. King Henry doesn't usually drink chocolate milk. And you can see all the first letters have been emphasized here. So we have our kilo, hecto, deca, U for the name of the unit, or one, deci, centi, milli. Okay, so pretty easy to remember that. King Henry doesn't usually drink chocolate milk. Okay, and so they're all based on powers of 10 here. All right, so what would I do to do a measurement? Well, there's actually two different ways of doing these measurements. One is using the idea of a unit fraction or those identity ratios. And another way is just, thinking about the powers of 10 and sliding the decimal. So let's look at the first way and using the unit fraction idea. So it says here, it says a centimeter is 1/100th of a meter. Okay, so 1/100th of the meter. In other words, it takes 100 centimeters to make 1 meter. Okay, that's what that means. So here would be my two identity ratios if I wanted to do something like that. Now look at a kilometer or a kilometer. Okay, that's 1,000 meters. So what identity ratios would I use? Well, 1 kilometer is the same thing as 1,000 meters, or the reciprocal of that, flip it. Okay, so a millimeter is 1/1,000th of a meter. What identity ratio would we use? So 1 meter is 1,000 millimeters. Okay, or 1,000 millimeters is the same thing as 1 meter. Okay, so here's how you can do it using the idea of identity ratios. So if you were going to be converting, and it says the average racehorse weighs 500 kilograms, so my unit is grams, all right? So kilograms is how many grams? Well, we know that there are 1,000 grams in 1 kilogram. So start with what I know, that's 500 kilograms, and usually I like to put that over 1. Kilograms are going to cancel each other out, and then you can see grams is in my final answer. So follow the rules of fraction. In this case, I multiply my numerators and get 500,000 grams. Okay. Here's another example converting centimeters to kilometers. You can take a look at that. Okay, notice in this case, we went first from centimeters to meters, then we converted from meters to kilometers. So we first went back to the actual unit, then from the unit, we went to kilometers. So this one is one that had multiple steps involved here. So like I said, this is the first way using the identity ratios. Me personally, I like to use the second way, which is what most of metric countries use, and that's the sliding of the decimal method. So let's look at the steps here. It says write out the metric prefixes. Okay, so in other words, you're going to have this on your conversion sheet. That's about the middle of the page there. It's already there for you to be able to use on the exam. Place a decimal point immediately to the right of the unit you are converting from. Okay, so let's look at this example. It says 5.2 kilograms. Okay, so 5.2 kilograms is going to be right here. Here's 5.2 because it's 5 kilograms plus a little extra, right? All right, so if we want to convert kilograms to milligrams, we're going to basically see how many places do I need to move this decimal. Well, I'm at kilograms here, and I want to get to milligrams. So I just want to see how many places am I going to have to move my decimal. Don't count where you began. Okay, you don't count this one. You're going to count how many places now to the next one. I'm going to go 1, 2, 3, 4, 5, 6 places to the right. that means I'm going to move my decimal 6 places to the right. Now, in order to do that appropriately, I'm going to have to add some zeros in there as place markers here. So 5.2 kilograms is the same thing as 5,200,000 milligrams. So it's really easy to do the conversions by just literally, here's the unit I'm at. Where do I want to go to? I'm just going to move back and forth my decimal here. Okay. Here's a couple other examples here for you. Okay. How many centigrams, how many hectograms, and how many grams? Notice how you just move the decimal. Okay, and you can also move the decimal to the left. So if I'm at milliliters, milli is way down here. Okay, and I want to go to kiloliters. Okay, how many places am I going to move? Well, I'm at milliliters, so I'm going to have to go 1, 2, 3, 4, 5, 6 places to the left. Well, if my decimal was at the end of 24 to begin with, that means I have to move it over 6 places. Okay? Same idea, just going in the opposite direction here. Okay, here's a couple others. Hair grows at an average of 15.24 centimeters each year. How many decimeters is that and how many meters? So just use that idea to move that decimal. Okay, now the tricky part comes in when we're going to be converting from the metric system to the English system, or from English system to the metric system, back and forth. This is where it gets a little bit tricky. Now, if you look at your that yellow conversion sheet there in your book, you'll get the same exact little chart here. And I want you to notice a couple of things here. Notice I've got these little squiggly equal signs here on all of them except for one. All right, that squiggly equal sign means an approximation. We're getting as close to that conversion, but it's not the exact conversion. The only one that we have between the US customary and the metric system that's an exact measurement is inches to centimeters. 1 inch is exactly 2.54 centimeters. Okay, everything else is an approximation. Okay, so let's take a look at this. All right, so we also have, so if I were, let's see, each line of the table represents a unit fraction. Okay, so if I were to say 1 kilogram is, or this many kilograms is the same thing as 1 pound. Okay, recall that ratios can be written in many forms. If I were to divide 1 by this value, we would get 2.2 pounds per 1 kilogram. So if you are somebody in the medical field already, most of the people in the medical field use this conversion factor. Even though it's not on our page here, they use 2.2 pounds per kilogram. Okay, so when you're looking at something like that, I mean, it's okay to use that when you're in the field, but I do know that WebWorks is a little particular, and most of the time WebWorks wants you to use the actual conversion here, okay, with the pounds and kilograms that's on the sheet, okay, because they know that most people wouldn't know this 2.2 pounds per 1 kilogram. But that is a valid way of using it. So if for some reason you use that conversion on the exam and you get a different answer that shows it's slightly off, because there'll be a slightly different value sometimes, just make sure you have that written on your scrap paper so I can see that, oh, you use that conversion rate instead of 1 pound is 0.4536 kilograms. Okay, because sometimes it's a little bit different, just slightly off. Okay, so here's a couple examples how we would do that. We're going to set up those Identity ratios, same way. Okay, so to go from inches to centimeters, here's what I began with. I want inches in the denominator so they cancel out. Follow the rules of fractions, and I get 5.08 centimeters. Now, be careful. Just watch. In this section, they're going to be pretty particular about how many decimal points they want you to round it out to, and you need to make sure that that last decimal place is rounded appropriately. So if they say to round it to the nearest hundredth, okay, that would be 5.08. If they would have said rounded to the nearest tenth, okay, tenth is the first decimal, so it would be what? 5.1, because this is a number greater than 5, okay? Here's going in the opposite direction from centimeters to inches. We use the opposite of that identity ratio. Okay, and notice in this case it's an approximation because we had to round it out to a certain number of decimal places. Now look at this one. It says convert 245 centimeters to yards. Well, when I look at my conversion factor, when I look up here, I don't have anything that takes me from centimeters to yards. I don't have that. So I have to do the next best thing. First, I can convert centimeters to inches. Okay, so I can at least get out of the decimal system or the metric system. And that's what I did first. I got out of the metric system by doing this conversion to inches. Now I know that there are what? 12 inches in 1 foot and then 3 feet in 1 yard. Or you could have used an abbreviation. If you already know there are 36 inches in a yard, you could have used that conversion factor. So keep in mind, if you don't see the conversion factor right away there on the page, you have to convert to the next best thing, then use the rest of the conversion factor. So in this case, we converted, got out of the metric system. Now I can go from the English system to where I needed to go. Okay, and then once again, be careful and watch how much they want you to round it out to. Okay, so here's just some typical ways we would use these measurements here in the English system and the metric system. I find these kind of interesting because, you know, something we don't normally come across. When we talk about converting with medications, you know, we come into the hospital, we know how many pounds we weigh, but the first thing they're going to do is convert us to kilograms because all the medications are in the metric system. Okay. All right, here's another conversion factor where first we have to convert and get out of the metric system into the English system, then we could convert from there. Okay, here's another one. Like I said, you know, this is the first thing that's going to happen when you go to the hospital. They're going to convert your weight to kilograms. And they're going to round it out, usually to the nearest whole amount. So here's from inches to centimeters. And here's just a couple of more. So notice that everything we've been talking about converting so far has been basically, we start with 1 unit, we want to end with 1 unit. Okay, so that's just a basic conversion factor there. There's a different kind of a measurement called a rate, and a rate actually starts with 2 units to begin with. All right, so this is the only time where we might not necessarily wind up with the final unit in the numerator because we started out with 2 units. So in this case, It says, suppose a car is traveling 35 mph. Remember, that stands for miles per hour. Per means to divide. So if I were going to convert this to feet per minute, I want to start with what I know. So I'm going to write it out in the long version. So I'm going to start with 35 miles. Per means to divide, and then hours. So that's 1 hour. So I'm starting with 2 units to begin with. That means I'm dealing with a rate. Now I want to convert from miles per hour to feet per minute. Honestly, it doesn't matter which one you start converting first as long as you do it in the correct order. All right, so I want to get rid of miles and go to feet. And feet has to be in the numerator because this is where the miles started out to be. So I can use this idea. I've got a conversion that takes me right away from miles to feet. Okay, so miles will cancel out and 5,280 feet is in a mile. Okay, feet is in the numerator, which is where I want it because it's saying feet per minute. So feet is in the numerator. Now the next thing, I want to get rid of hour. All right, so I need to cancel out hour, and we know 1 hour is the same thing as 60 minutes. So hour is going to cancel out with the hour over here. Minutes is where I want it to be in the denominator because I want feet per minute. Okay, and now I follow the rules of fractions, multiply my numerators, multiply my denominators, do the division at the very end, and I wind up with 3,080 feet per minute. Okay, so that's the only time where we're going to actually have 2 units there, and that's when we're dealing with a rate. So let's take a look at a few more examples here. Okay, so in this case, notice they didn't convert the time. They only converted the unit of measure. Okay, so they went from kilometers per hour to miles per hour. So they just converted kilometers to miles. And it just so happens there is a conversion from kilometers to hours. I'm sorry, to miles. Sorry about that. And hours didn't have to change. Okay, here's one. Suppose the resting heartbeat is 70 beats per minute. So how many times is your heart going to beat in an hour? All right. I'm not going to have to convert the beats. I'm just going to convert the time factor. Oop. Okay. So you buy a pump that is rated 2,500 gallons per hour. How fast can it pump in liters per minute? So in this case, I'm going to have to convert both. I'm going to have to go from gallons to liters and then from hours to minutes. So in this case, they decided to first go from gallons to liters. Well, when you look on your conversion sheet, there isn't a conversion that takes me from gallons to liters. So I had to go to the next best thing. I had to convert from gallons to quarts because then I can see on my conversion sheet there is a conversion from quarts to liters. So that's what I did in that particular order here. That's why I did this. I had to do the next best unit I could find. Now I can convert from quarts to liters, and I've got what I need here. Okay, so liters is in the numerator where I want it to be. And I want to now go from hours to minutes. And I know that I want to get rid of hours. So 1 hour is the same thing as 60 minutes. Follow your rules of fractions. Multiply my numerators, multiply my denominators, do your division at the end, and I get approximately 157.7 liters per minute. Okay. Okay. Let's take a look at this. How long will the trip take traveling 55 miles per hour if I go 120 miles? Oops, sorry, over here, 120 miles from Lafayette to Fort Wayne. If somebody travels an average speed of 65 miles, how long will the trip take? It's going to take about this many hours. Now, what if I converted that to 55 miles per hour and I change that? That would raise the number of, since we're going a little slower, that would increase our time factor there. Okay, so here is something to think about. A hybrid can get 47 miles per gallon. How much fuel will it take to drive from Lafayette to Fort Wayne using the current gas prices? This is just kind of interesting to see. These are some questions out there that, you might be able to kind of calculate there. Okay, here's something that we might deal with something. If there are 15,000 gallons of water in your basement, how long will it take the 2,500 gallon per hour pump to pump out all the water? Okay, so what if you flooded and you needed to pump out some water? How long is that going to take? So you're dealing with something, this pump has a rate, so I can multiply this number of gallons times the rate, and gallons will cancel out, and I'm left with just hours in my answer here. Okay, so our next conversions, and we do have the formulas there, are temperature conversions. So Fahrenheit is what we're very much used to using, and Celsius is the metric system. Okay, pretty much, this is just a page here that shows you how they got to these formulas here. You don't have to memorize that. We're just going to be simply using these conversion factors. Okay, the most important thing though is to understand a little bit about the temperatures here. And you can see the conversions between Fahrenheit and centimeters, where water boils, what is the typical body temperature. So if you kind of understand, water freezes 32 versus 0 and so on. Okay, when we're using the conversion factors with temperature, the most important thing is to follow the order of operations. Notice it even says here, follow the order of operations. Remember that, please excuse my dear Aunt Sally, parentheses is first. So if I'm converting from Fahrenheit to Celsius, I have to take care of what's in the parentheses first. So do that subtraction, then multiply by 5/9. Okay, so once again, just use your rules of fractions here. Okay, in this case, from Celsius to Fahrenheit, I have no parentheses. I have no exponents. So the next thing I'm going to do is multiply or divide. So in this case, I'm going to multiply 9/5 times the degrees Celsius. And then finally, I'm going to add 32 to that. So in this case, you get sick in Montreal and go to a clinic. The nurse says your temperature is 38 degrees. Should you be concerned? Because, you have no point of reference. We use Fahrenheit all the time. So if you do the conversion, you have a little bit of an elevated fever, 100.4. Okay, a comfortable room temperature is 72 degrees Fahrenheit. What is that in Celsius? So once again, follow those order of operations here. Do what's in the parentheses, then multiply by 5/9 or 5/9. You need to refrigerate your potato salad at 39 degrees Fahrenheit. What temperature should your refrigerator be at Celsius? approximately just under 4 degrees Celsius. Okay, there are some money conversions here that you might run into for doing some of the WebWorks problems, but that's not one of our conversion factors that you see on a regular basis because currency conversions change on a daily basis. So you might run into a few problems just to help you understand that, and they'll give you the conversion factors there. Okay, and these were just some examples there. Okay, so pretty much these are the basic conversions. Let me see here. These are some of the practice problems at the end. Once again, it shows you to convert between things. A swimming pool is a rate of 15 pints per minute. How many gallons per hour is that? So it's just a matter of doing the conversion factors. Here's a bonus slide here. If you're interested in writing these down, they're talking about a millisecond. Okay, so I'll leave this slide up here. And pretty much this is all I have for you today on our conversions. We're going to be getting into more of two and 3-dimensional conversion factors in our next class, and we'll do some more application problems in our next class. But this is just the beginnings of doing the conversions here. So remember, if you don't see the conversion exactly from one to the next, use the next best thing. You want to get into practice of that, and then find the conversion factor on the page there. Okay, so if you have no other questions, I will talk with you next week. Good luck on everything that's due this week.